So you got pi r squared
What's pi r squared?
circle area formula.
Area. Okay,
Um,
let's call it.
and then the radius is 5, so that should be 10 or 25 pi.
Well, if you plug in the radius, that just tells you what the area is, but we don't really
Yeah.
care about the area. We care about the rate of change of area. So let's talk about this. The radius of the circle decreases the rate of this, right? What expression represents the rate of the radius?
Rate of change of the radius. Oh, the derivative of the radius.
What are the units of the rate of change?
Centimeters per minute.
Yeah, per minute. What's the derivative with respect to what? The change in the radius over change in what?
Over change in time.
Time, right? So
Change
what's
in radius
represents,
with respect to time.
yeah, dr dt. That's what this is. And then what's the change rate of change of the area? What will represent that?
dA dt.
dA dt. Okay. Does that make sense?
Yeah.
So we need to find how the rate of change of area is affected by the rate of change of time, which means we have to work with the variables a and r. So we already have our formula with a and r. How do we get this so that we get dr dt and dA dt to appear? Or what do we have
Um,
to do to this
take the
formula?
derivative. Take the derivative of that. So
Yeah.
it's dA dt equals 2r times dr dt.
What else is there?
Whoa, 2 pi r.
Yeah, pi is a coefficient. It's a number. So it
2
stays.
pi r times
And
dr dt.
drd. Okay.
And then that means rate of change of area. So you just plug in 5 for r now, which is 10 pi
Anything else?
dr. Oh, and then dr dt is 4. So 40 pi.
Well, what else is happening with the radius?
The radius is decreasing.
Okay, so what's that tell you about its derivative?
Should be negative.
Negative. Yeah.
So it's negative 40 pi. Yeah.
The negative derivative means the radius would be decreasing. Positive derivative would mean that the radius is increasing. Okay. So then what you got?
Negative 40 pi.
Yeah, negative 40 pi. Okay. What are the units?
Centimeters per minute.
What's this?
Oh,
What rate is this for?
it's for the area.
Yeah, what's that measured in? Or what are the units that go with area?
Oh, centimeters squared per minute.
Yeah. Okay, that makes sense.
Yeah.
Okay.
Okay. It has to be positive because increasing.
Okay.
Oh, rate of increase. It's the same with an area of a circle, but it's also using circumference.
Okay.
Okay. At the instant where the circumference of the circle is 20 pi meters. So dr dt would be 0.2.
Okay.
And we're trying to find dA dt at 20 pi.
Okay. At what is 20 pi?
Circumference is 20 pi.
Okay.
So it's a. Oh, well, should I set circumference? Should I say 20 pi equals 2 pi r and then find what the radius is?
Okay. Yeah, that's what you
Yeah.
were supposed to do.
Okay. So 20 pi equals pi r. So our radius would be 10. dA dt equals 2 pi or 20 pi dr dt,
Okay, how'd you get that?
because the derivative is 2 pi r dr dt, and then just plug in 10 for r.
Yeah, because 2 pi r drt. Okay, yep, can use it
So-
from last time.
Times 0.2, because times up by 0.2, and you get 20. So dAdt equals 4 pi.
20 times 0.2, 4 pi. Yeah. What are the units?
4 pi meters squared per second.
Yeah. Okay, yep, that looks good.